Hello everyone, welcome to EEEE lecture number 11B. Today we are going to solve another practice test, that is set B, based on module number 1, that is DC circuits. So let's start solving question number 1A. So in the following network, determine the current supplied by the 50 volt battery. Alright, so we need to determine the current flowing supplied by the 50-volt battery. So let's start with a numerical. So first of all, there is no mention strategy or analysis given. That means we can apply MES or any other analysis or any theorem. So from the numerical diagram, we can see that there are three loops, loop number 1, 2 and 3. So we can easily apply the MES analysis. All right. So we'll mark the current direction and the current notation I1 here. Here it will be I2, and over here we'll mark it as I3. All right. So we will be solving it by mesh analysis. So according to mesh analysis, we will apply KVL in each individual loops. So let's start by applying KVL to loop number 1. So KVL to loop 1. So what does it say? You're going from minus plus, so rise in potential. So 50 minus twice I1 minus 6. I1 minus I2, I1 minus I2 minus 4, I1 minus I3. All right, I arrange it in terms of I1, I2 and I3. So it will be minus 12 I1 plus 6 I2 plus 4 I3 is equal to minus 50. Let's call this equation number 1. So there are three unknowns, I1, I2 and I3. We require three equations. So we'll apply KVL now to loop 2. So loop 2 is over here. Okay, let me mark it. So this is my loop number 2. So it says that 6 ohm resistance is set between 1 and 2, loop 1 and 2. 5 ohm resistance is set between loop 2 and 3. So we can write over here minus 6 I2 minus I1 minus 5 I2 minus I3 minus 2 I2 is equal to 0. So we club the terms together and we get 6 I1 minus 13 I2 plus 5 I3 is equal to 0. Let's call this equation number 2. Alright. Now we apply the KVL to the third loop. So this loop we will apply. I'm marking it with green color over here. Alright. So we'll write KVL to loop 3. So what do we get? This 4 ohm is set between loop 3 and 1. 5 ohm is set between loop 3 and 2. So we get minus 4 I3 minus I1 minus 5 I3 minus I2 minus 3 I3 is equal to 0. So we rearrange the terms and what do we get? 4 I1 plus 5 I2 minus 12 I3 is equal to 0. So let's call this equation number 3. So from 1, 2 and 3 we can put it in a matrix form. Let me write it over here. So this is I1, I2, I3. There are three coefficients, I1, I2 and I3 terms are there. Then here the first coefficient of I1 in equation number 1 is minus 12, 6, 4, and here it will be minus 50. Alright, in the second equation number 2, this will be 6 minus 13, 5 and 0. And the third 4, 5 minus 12, 0. Alright, so solve this in simultaneously and let me know the answer of I1, I2 and I3. Alright, so I1 is coming out to be 3275 amperes divided by 346. Alright, and actually we require I1 only. So I1 is nothing but current flowing through 50 volt battery, and that is coming out to be 9.4653 amperes. So that is the value of the current supplied by 50 volt battery. Alright, and it was asked for 10 marks. Okay, fine. So we go to the next numerical, that is numerical number 1b. 1A was asked for 10 marks, so 1A marks are 5. So once you get the value of I of current supplied by 50-volt battery, this will fetch you 5 marks. All right. Now let's go to question number 1B. We need to find the equivalent resistance between A and B. So let me redraw this network again. Let me maximize this part. So let's call this as over here. This is C and this is D. So let me redraw this network carefully. So let's say this is A, all right, and I'll first draw A and D, then this will be B, and between B and C, all right, and let me draw the network now. So this is A. So between A and C, what do we have? 10 ohms. So between A and C, we have 10 ohm resistance. Between C and D, what do we have? Another 10 ohm resistance. All right. Then between B and D and B, another 10 ohm resistance. All right. And then between B and C, we have 10 ohm, B and C. Then between A and D, we have 10 ohm resistance. And we need to find the equivalent resistance between A and B. So between here and here. So we need to find RAB. So all are 10 ohm resistance. So how do we solve this further? If you see carefully, this is my delta network. Let me mark my delta network. This is my delta network. I would like to convert it into star. So internal diagram, I'll make a star over here like this. All right. Let me mark this resistance as R1, R2, and R3. So I'll convert delta to star. So what is the formula? What will be R1? R1 will be um, R1 will be R2 into R3. That will be other resistance, right? So that will be here it is. This opposite of R1 is 10 ohms, right? And what are the adjacent resistance to R1? 10 and 10, right? So it will be 10 into 10 divided by total resistance 10 plus 10 plus 10. So that this will be uh, okay. This will be 100 upon 30. That will be 10 by 3 ohms. All right. Similarly, R2 will be R2 is over here. So adjacent resistance multiplication, that is 10 into 10 divided by 10 plus 10 plus 10. So that also will be 10 by 3 ohms. And R3 also will be 10 by 3 because all the resistance are same. All right. Now let me redraw the network over here and find the value of RAB. So I'm redrawing the network over here. Let me redraw the network over here. So here I have this star. The delta will go, now only star will remain. So this is A, all right. This is C, this is D. So this 10 ohms are gone. Now remaining 10 ohms are as follows. Okay, and this is point B. This value is 10 by 3. That will be 3.33. This will also will be 3.33 ohms, and this also will be 3.33 ohms. This will be 10 ohms. This will be 10 ohms. All right. So now we need to find the equivalent resistance between A and B. Now if you see carefully, these two resistances are in series. Similarly, these two resistances are in series. So how does the network goes now? So we have 3.33 ohms resistance, and then we have two resistance of value 10 plus 3.33, that will be 10.33 ohms, and here also we have 10.33 ohms. All right, and here we have B. This is A and this is B. So what will be RAB? Again over here 10.33 and 10.33 will be in parallel. So I can write it down, 10.33 parallel to 10.33, and oh sorry, not 10.33, it will be 13. So sorry for that. 10 plus 3.33, that will be 13.33, 13.33 ohms. All right. So here also there will be a change appropriate, 13.33 ohms. All right, and that comes out to be 6.666 ohms. So basically RAV will be this 3.33 ohms plus, because this will be in series, right? These two parallel combination will become 6.66. So it will be 3.333 plus 6.666. So that will come out close to be 10 ohms. All right. So RAB value is coming out to be 10 ohms. The equivalent resistance between point A and B is 10 ohm resistance. Okay. So now we go to numerical number 2. We need to find the current through 5 ohm resistance using mesh analysis. Okay. So this is my current through 5 ohm resistance. I can write it as I of 5 ohm, and we need to find the current through 5 ohm resistance now using mesh analysis. So let's start with our discussion. So for mesh analysis, we'll define 3 loops. So this is our loop number 1, I1. This is loop number 2, we'll define the current I2. And there is loop number 3, I3. Now if you immediately look a glance at the circuit, loop number 2 and 3 is sharing a current source. So which makes it a super mesh. So this is a concept of a super mesh. All right, and what is my super mesh? This is my current source which has been shared between loop number 2 and 3, and the circuit around it will be my super mesh. So this yellow color portion is my super mesh. So what will be the current defined by this current source according to super mesh? So here we can write I2 minus I3 is actually 2 amperes. So this becomes equation number 1. All right. Now, since we are applying mesh analysis and we have a super mesh, so we'll apply KVL to super mesh. Basically, the yellow color part which we have marked. So here the current will be minus 5 I3 minus I1. So minus 5 I3 minus I1 minus, here we don't have to go over here, minus 10 I2 minus I1, then minus 2 I2, and here will come down, it will be minus I3 is equal to 0. We rearrange the terms, we'll get 15 I1 minus 12 I2 minus 6 I3 is equal to 0. Let's call this equation number 2. Now my loop number 1 is my normal loop, so we apply KVL to loop 1. Okay, so what do we get? This is minus plus, so rise in potential 50 minus 10. It is said between 10 ohm resistance is said between first loop and second loop. So it will be I1 minus I2 minus 5 I1 minus I3, and this is equal to 0. So we can write it as over here minus 15 I1 plus 10 I2 plus 5 I3 is equal to minus 50. This becomes equation number 3. Now we have 3 equations and 3 unknowns. So we can write it in a matrix form. This is I1, I2, I3, and we can write the values over here. So let me see, this is the equation number 1. So here I1 was absent coefficient, so it will be 0, 1, minus 1, and here we'll have 2. All right, here this coefficient will be 15 minus 12 minus 6, and here 0. And the last coefficient will be minus 15, 10, 5, and minus 50. All right, so this will be the equations. So now we'll have to solve this simultaneously, and we'll get the value of current flowing through 5 ohm resistance is what? It's basically I1 minus I3. So we required a value of I1 and I3. So I1 is coming out to be 20 amperes. I2 is coming out to be 52 by 3 amperes. Please check out your answers. And I3 is coming out to be 46 by 3 amperes. So what is I of 5 ohm resistance will be 20 amperes minus 46 by 3. So that comes out to be, if you solve it, you will get it as 4.6667 amperes, and the direction is flowing down. So this is my value of current through 5 ohm resistance using mesh analysis. All right, and this will fetch you 10 marks. I know I have done all the working, all the writing work around the numerical itself, but you all have to systematically solve it one below the other. All right. So yeah, so these are the answers for current flowing through 5 ohm resistance is 4.6667 amperes. Now, next numerical number 3, and as the last one, we need to find the current flowing through 40 ohm resistance using Thevenin's theorem. So let's start. So for Thevenin's theorem, first we require to find RTH. RTH is the Thevenin's resistance. So for RTH, we need to remove RL, and we need to deactivate the source. That means short circuit 2-volt voltage source. So let's do that. So first of all, let me redraw the circuit. So I have drawn the circuit over here. So these resistance are 20 ohm. Basically, this is my point 4 ohm. For we have to find the current through 40 ohm, right? So these are my points A and B, and this is my load resistance RL. So we need to find current flowing through this load resistance RL. So these are my points A and B. All right. This is the voltage. This is around 15 ohms, 30 ohms, 10 ohms. So we need to short circuit the voltage source. So these 2 points will be short circuited. Let me short circuit from inside only. All right, and we need to remove RL. We have removed RL, and we need to find the equivalent resistance between points A and B. Okay, between terminals A and B. If you look carefully, these 2 points, that is 10 ohm and 30 ohm, are in parallel, and this 20 ohm and 15 ohm are in parallel. All right, so 10 ohm parallel to 30 ohm over here. All right, and here you will get it as 20 ohm parallel to 15 ohm. So if I redraw the network down, right, so what do I get over here? 10 ohm parallel to 30 ohm will be around 7.5 ohm, and 20 parallel to 15 will be 8.5714 ohms. All right, now let me redraw the network over here. So we have two resistance. These are point A and B. This is 7.5. This is 8.5714. If you see carefully, these two resistance are in series. So what will be RAB or RTH? So RAB will be equal to, RTH is equal to 7.5 plus 8.5714, and that comes out to be 16.07 ohms. Okay, so that is my value of RTH, Thevenin's resistance. Now next we'll calculate VTH. Alright, so let's take this side for VTH, and let me use green color. So we need to find VTH. For finding VTH, what is the procedure? We need to remove RL, and second is find open circuit voltage between A and B. Alright, so let me redraw the network. So here is my 10 ohm resistance, 30 ohm resistance. Here it is 20 ohm resistance, and here is my 15 ohm resistance. These are my points A, terminals A and B. This is 10 ohm resistance. So what I will do is, instead of, we have removed the value of removed the load RL resistance, instead of showing this 2 volt outside, I just show it from inside like this. Okay, it means one and the same. Let me highlight this part. Now if I see carefully, we can solve this using simple Ohm's law. Now what is the current flowing through this loop? I1. Let me call it as I1, and let me call it current flowing over here as I2. So we can find I1 and I2 very easily. What will be I1? I1 will be 2 volt divided by 10 plus 30. So yeah, Ohm's law, simple Ohm's law. So it will be 2 by 40. That will be 1 by 20 amperes. Similarly, I2 will be 2 volt divided by 20 plus 15. So I2 will come out to be 2 upon 35 amperes. Alright. Now, how will you calculate VAB? So for calculate VAB, you always start from below. So start from B and then go to A. Alright. So what will be VAB? VAB will be, here we are going in the direction of the current. So we are going from B to A. So we can write over here. I mean, either we can go from here to here, or we can go from here to here. Okay, we are going from here to here. So what do we get? 20, I mean, we are going in the direction of the current, so it will be negative only. So it will be minus 15 I2 plus, now we are going above and the current is reverse, so it will be plus 30 I1. So minus 15 I2 plus 30 I1. So minus 15 into I2, 2 by 35 plus 30 into 1 by 20. So if you solve this further, VAV will come out to be, which is equal to VTH, that will come out to be 0.6428 volt. All right. So that's the value of VTH. You can solve this out. Let me check the value of VTH once. So VTH is 15 into 2. That will be minus 30 divided by 35. Okay. And plus 3 by 2. That will be 1.5. So this comes out to be 0.6428. That's perfectly all right. So your value of VAB or VTH is fine. And now what are we actually finding? We are finding the current through 40 ohm resistance. So we need to draw the Thevenin's equivalent circuit. So we'll draw the Thevenin's equivalent circuit over here. So which will be a single voltage source in series with the resistance RTH. This is VTH, and these are points A and B, and we connect a resistor over here, RL. So what will be the current flowing to this resistor? So IRL will be uh, VTH upon simple Ohm's law, RTH plus RL. So basically VTH is 0.6428 divided by RTH is 16.07 plus RL value is how much? RL value is around 40 ohms plus 40. So this will be around 0.01146 amperes direction down. So this is the current which is flowing through 40 ohm 40 ohm resistance, which we have found out using Thevenin's theorem. So you can check it out. This is the current flowing through 40 ohm resistance. All right. So yeah, this is the answer, and that's all for the lecture.